Well, even we told Ruby it's Jackson.
Jackson's the president. I think so. Sarah, VP of Service in the British Republic.
The NEHS? Y'all's lineup with Loki's so good.
I'm rather than that. Bridge said he thought it was going to be ahead of him, but then he said it's I don't know. Like I have hope, but I'm not like.
I did it.
It's either 2 or 3.
Do you have any note cards that I can use for fun?
I do somewhere.
Yeah, so Sylvia's VP of Service, so she can.
Check
Good morning, SHS.
Check on that
Today
blue
is
thing in the
Friday,
very
May
corner.
3rd, 2024. Please join me in a minute of silence.
Colin, did you find one? Okay.
Please stand if you are able and join me in the pledge. Of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Caesar, today is your last day. We wish you the very best, and everyone have a great day and a great weekend.
All right, good morning, guys. So we built in one extra day because I knew I would not be here with you guys last class for to finish up 2.5 together. So that's why your 2.5 quiz is not today, but will be next class. So I've got a tiny bit more practice for you that I'll explain in just a second. And then I'll give you a chance to, I know the class website had some videos on the book assignment. but I know those are not always sufficient. So if there were still some of those you needed extra help with, then we've got some time to get that done today. But we are on a different schedule today for the moving up ceremony. So just in case you didn't see this in student announcements, I'm going to put it up on the screen for a second. And if you'd like to take a picture, this is your chance. But again, it should be in your student announcements. The big difference is with advisory at the end of the day, you're going to go straight to third period, and so that could even be potentially lunch after this class, depending on where your third period class is. Okay, anybody still want to take a picture while it's up? Okay. So what I'd like you to do for some extra practice today, and then I'll take your questions that you may have had from the book assignment after I go over all the announcements and stuff. But I went ahead and passed out the semester test review to you. Obviously, you've got your semester test coming up in a few weeks. And, I know some of you plan on being exempt or trying to be exempt. But of course, sometimes people want to be exempt, and then they realize that, there is a requirement tied to advisory and they didn't realize that or something. So we need to be moving in that direction until you get the official word that you are exempt. And like last semester, the semester test review will probably be required. It really just depends on how much class time we give you to work on it. But the ones I'm asking you to today are just questions 33, 34, 35, 36, and 37. So that's 5 questions from it. And it's not that I'm necessarily that interested in you starting the semester test review this early, but those 5 questions are skills that will be on next class's quiz. So obviously if you're struggling with those, that gives you 5 more practice questions, 5 more chances to get it right before you take the quiz. And then of course you've also got 5 questions from the semester test review done that way. So that's the extra practice I have for you today, and obviously I'd be happy to help you with that once I think you've had all had time to do that. But the announcements I need to tell you, so I will be taking a grade on 17, 18, and 19. I did ask for you to turn those in last time, but I will still take them for full credit since I wasn't here last time, as long as you get them to me before the quiz on Monday. We'll be doing the quiz Monday morning. So if you didn't turn those in, you probably should make an effort to turn them in today. And in just a second, well, I'll remind you what those 3 assignments are. 117 is where we practice long division and synthetic division at the same time. 118 was the book assignment that I'm about to take a few questions from, if there's a few I can help from since I was not here last class. And then 119 is the book assignment. 118 was a 2.5 worksheet. And you can see under the agenda, that is the thing that looks the most like what your quiz will look like on Monday. So make sure you put eyes back on 118. Any of those questions you feel like you might struggle to do, you might work them on a separate sheet of paper and then compare and make sure that you've got the same thing. Okay, and then you should have plenty of time to study for the 2.5 quiz, where you shouldn't need to do much of that, if any of that, for homework. But I know some of you are going to feel more prepared for that than others. So I certainly encourage you to work some other questions on the semester test review if you have time. Obviously, the more of it you do now, it will just be that much less you have to do later. So not more work, just spreading it a little thinner. Okay, so if you don't have any book questions, go ahead and please start the 33 through 37 on the semester test review. And if you do have any book questions that the class video was not enough help for last class, then go ahead and find those and let me know what they are, and then I can go over all the questions that you had. And I'm ready whenever, so just tell me when you find them. Okay, if you change your mind, obviously there's plenty of time, so I'd be happy to take any questions from the book assignment last time. I'd be happy to take any of these 5 questions from the semester test review. And then again, just make sure that you use this time to study until you feel like you're ready. And then I guess after that, if you try some other questions from the semester test review that you don't remember how to do, I could also help you with those. But I'll give you a few minutes to work on whatever you're working on before I bug you for more questions again. I also have the solutions and a lot of help videos for the semester test review. So if you're working ahead on that at some point today, you might want to start using those too. Okay, just checking in. Is there anything from 33 through 37 or anything from the book assignment that you have found I can help with? 30 what?
31.
31, sure. We're talking about from the book assignment. Okay, so this question says find all of the real zeros. And to be fair, this question could start off a lot of different ways depending on what we offer you on your quiz. So just like on the agenda, this is a no calculator quiz, so that's going to impact how I work this a little bit. But the fact that this is a 4th degree means that it has 4 zeros. But that's not what they're asking for. They're asking for how many of them are real zeros. And so what we would do to kind of help you out here is, oh, we still need to talk about question 15 and 16. I'm sorry, I forgot that I didn't do that one with y'all. We need to do those. I guess some of you must have watched the videos to see how to do that. But. So if you use that rational zero test, which I will talk about with questions 15 and 16, I forgot that your class didn't get that. You can make a list of possible zeros that are likely to be zeros but not guaranteed. And then in theory, you could try to synthetically divide one of them out. If you got a remainder of 0, you would have one of your zeros. If you didn't get a remainder of 0, you could just try a different one. And also, if you could find 2 of them, you could divide the first one out to reduce this to a 3rd degree, and then reduce the second one out to get it to a 2nd degree. And then you wouldn't have to guess and check anymore because you could use quadratic formula. But we would not do that to you on the quiz, even though hopefully you did a little bit of that in Algebra 2. So what we would have to do is either A, give you a calculator for you to graph it, which we're not going to do. B, we would have to give you a 0 or 2 to start off with, so that you could divide those out to find the other hidden ones. Or C, we would give you the graph. We will graph it on your quiz for you. So let me talk about those last 2 ways because that is what's going to happen to you on our quiz. So if we do this, if we put the graph on your quiz, I can see that it clearly goes through one, and 1's a real number, so that's part. Again, this is really what they want. There's no guarantee that all 4 are going to be real. Also looking at my graph, it looks like it goes through -3. So -3 is a 0, and -3 is a real number, so we need to include that as our answer. But then there's 2 others that are a little harder to see. One of them looks like it's at a half, but it's actually not. And another one's at about -4.5, but it's actually not. So what you have to do to find these last 2, now again, the first half of this question could go one of 2 ways. We might just tell you these 2 in the directions and then do what I'm about to do, or we could give you the graph and you need to see these 2 from the x-axis. But to find the other 2, since they're apparently not nice whole numbers and they're not something like 1/2 or 1/3 that I'm going to guess, this is where the division comes into play. If I know 1 is a 0, 1 should divide into this evenly and leave a remainder of 0. So you could either synthetically divide by 1, or you could long divide by x minus 1, whatever you prefer. And again, you should know that it goes into it evenly. So add down and multiply, add down and multiply, add down and multiply, add down and multiply, and confirm. And the reason this is a step in the right direction is I just got it from a 4th degree down to a 3rd degree. Now if I divide out the other one that I'm sure about, it's going to take it from a 3rd degree down to a 2nd degree. and it was a 0 also, so it should go into it evenly, give us a remainder of 0. And then this stuff is now represents a quadratic, and with the quadratic we can try to factor it, although this one doesn't factor, or very, very worst case, we could at least do quadratic formula. Let's see, this would be 8 square root of 24. And then that reduces to -2 plus the square root of 6, 2 plus the square root of 6, and -2 minus the square root of 6. So, nothing I would have ever guessed, but those are considered real zeros because they show up as x-intercepts, and they don't have an I in them, so they're not imaginary. But again, there's no way you're just going to pull those out of the air. You have to take a couple that you are either given or you can see on the graph, divide the polynomial enough times that you can get it down to a quadratic, and then of course with the quadratic we hope it factors, but even if it doesn't, we could at least do quadratic formula. So, I don't know, y'all probably disagree with me, but I really like these question types because it's not just try synthetic division and see if you can do it, and look at a graph and see if you can find the zeros. It's really trying to pull together a few different skills, so to work something a little higher thought process needed. Okay, is that enough for 31? Okay. Anybody else that's going to ask about 31 need to ask anything specific while it's up? Okay, then others from the book or those 5 from the semester test review. Any questions you have ready to go? Okay, I'll check back in just a little bit. So if you get hard stuck, just move along, put a star by it, and I'll address it when we get there. Remember, we do have a slightly shorter class today. It's only shorter by 5 minutes, so it won't really matter too much, but keep that in mind as you guys are working. Okay, before I take a few more questions, again, I did say I wanted to talk about 15 and 16 real quick. I will admit that this is not something that is going to be big on the quiz or anything, but I believe lately, the last few years, they've been showing you this in Algebra 2, but didn't spend much time on it. And the unfortunate part of that is that this is very common on the ACT, and it doesn't take a lot of practice to understand what it's talking about. Actually, it doesn't take but about 15 seconds to get the answer. It's a little bit harder to understand why you should care about this. But the rational zero test says that the only possible, so this is not the zeros, this guy has 3 zeros, but the only possible zeros that could be rational numbers have to come from this list where we take plus or minus all the factors of what most people call P and divide it by plus or minus all the factors of what we call Q. So the first question you should have is, what in the world is P and Q? So P is the constant. Now, since it's plus or minus already, it doesn't really matter that it's a -2. And Q is the leading coefficient. Leading coefficient just means the number that's being multiplied by x with the biggest exponent. So, to answer question 15, you just have to do plus or minus all the factors of 2. So plus or minus anything that goes into 2 evenly. And then divide it by plus or minus all the factors of Q. Q is 1, so his only factors are 1. That's the answer that they're looking for in 15. So as I said, it's not hard to get the answer. It's a little more complicated to understand what it means and why you should care. And unfortunately, to really sell you on why you should care would make you have to practice a lot of stuff that we just don't hold you accountable for. But even on the ACT, they tend to write the questions like this or the answers like this in a compact format. But just so you know, you don't have to write them this long way for me. But just so you know, this basically means you could take any of these and put them over any of those. So you could put plus or minus 1 over plus or minus 1. A couple of those are repeats. And you could put plus or minus 2 over plus or minus 1. And again, a couple of those are repeats. But this is saying the same thing as these 4. Now, to try to explain to you why do people care about this? Why is this important enough for the ACT? Again, these list off the possible rational zeros. So this guy only has 3 zeros, so I'm not saying all 4 of these are 0. But of the rational numbers, these are the only ones that are possible. So that means 3 is not in this list, so there is 0% chance that 3 is an x-intercept. 2 is in this list, so 2 is likely to be a 0 for this polynomial, not guaranteed. If you really needed to know for sure, without a calculator, you could synthetically divide by one of these, and if you get a remainder, if you got a remainder of 0, you just found a 0 without being told it. And if you get a remainder that's not 0, then you just figured out that one of those is not one of the zeros. So the reason why they're showing you the graph over to the left is because they're trying to show you that every number that was in this list did show up as a rational 0. 1, -1, and +1. This guy had 3 rational zeros. All 3 of them had to be in that list. Now, the limitation of this is still useful because it only takes about 10 seconds of work to make this list. But the limitation is it's not going to help you find irrational zeros. So like this question that was asked a few minutes ago, square root of 6 is irrational. This is not going to show up in the rational zero test. It's not good enough, it's not smart enough to list those out as possibilities for you. And it's not designed in a way to list off imaginary zeros. So if there was any zeros with I in there, the rational zero test doesn't show you that. So to say the same things one more time with question 16, you actually need I forgot, you needed these for part A on a couple of these too. So 16, here's the function. Here's the graph that we can use for comparison. Looks like 2 and 4. 2, 4 x-intercepts, and -2. So they're showing us the graph to show us that our list better have those 3 numbers in there. So this is the whole thing. If I just need the answer, plus or minus the factors of p, which is really the constant. So plus or minus any number that goes into 16 evenly, over plus or minus the factors of q, which is the leading coefficient. And so this is what we're looking for as an answer. And again, that, as far as I know, still shows up on the ACT. And that's one of those things that if you review that for 2 minutes before you take the ACT, you'll probably remember how to do it. And if you don't, you may not. But again, this is just kind of a nice compact way. Any of these over any of these are possibilities. So this is a compact way to say it could be -1, +1, 2, or -2, or 4, or -4, or 8, or -8, or 16, or -16. Of the rational numbers, only these are possible to be zeros. So once again, 3 is not in this list. There was 0% chance 3 was going to be an x-intercept. There was 0% chance 3 was going to be a 0. But they showed us the graph so that we could see -2 is a 0. Notice how it was in the list. +2 is a 0. Notice how it was in the list. And +4 was a 0, which was also in the list. So all the rational zeros had to be in that P over Q list. And again, I don't know where the P over Q came from, but that's what most people call the rational zero test, the P over Q list. But the highlighted part would be the answer to that. Okay, so I did give you, I don't know, there was like 10 or 15 minutes before I interrupted you with that. So has anyone found 33 through 37 from test review, or anything from the book assignment last time that I can help with? Okay. Okay, we still got about 50 minutes, so we got time for me to offer help a couple more times. So go ahead and keep going, please.
the approval list came out. Your exemptions were denied from advisory absences, but you still get one exemption because you did the work keys on time. If you listed this class first, does that mean that was one you wanted to do? Okay. Making sure.
We can use a calculator on the advanced exam.
Mm-hmm. Yep.
And like, do we just come in on Monday and just like take the final?
Mm-hmm. That's during normal class time. we're down to about 25 minutes, so let me offer help on the board one last time. Anything from semester test review and or book assignment, or I guess even the long division, synthetic division worksheet.
Could you do 60 on the book assignment?
Sure, number 60. Okay, let's see. All right, so we've got a big polynomial function. They give us a 0. And we're supposed to leverage this 0 into finding all of the zeros. And it doesn't say just real zeros, it says find all zeros. So first thing I notice is this is a 4th degree, so in the end there should be 1, 2, 3, 4 zeros. That's the fundamental theorem of algebra. Degree tells you how many zeros there are. And having 1 0 honestly is not enough to get it all the way down and figure out all the rest of the zeros, especially without a calculator. So there's something special about this one, and you have to know this for our quiz. Imaginary zeros always come in conjugate pairs. Now actually yesterday somebody asked me about this too. They asked if this was the square root of 3 and then I was in the square root, or is I outside the square root? Now the textbook can print it this way, but when we write this we typically don't write it this way because it's kind of hard to tell. Depending on how much you drag the square root sign, it can look like this is under it. So technically, mathematically, it's fine, but most of the time when we write this stuff, we like to put the I out front just so there's no confusion about it being under the square root. In fact, I can't think of when you would have to get an I under a square root, you'd have to have a square root of something negative inside of another square root. So. Alright, so now you need to understand why some of these skills are related to each other. So if I could divide out both of these zeros, it would take this 4th degree down to a 2nd degree, and I know with the 2nd degree, worst case I could at least use quadratic formula to get the last 2 zeros. Now unfortunately I can't do synthetic division, divide out something like this. Synthetic division is only going to be helpful to divide out a number. So we're going to have to use long division. So first off, I need to change these to factors. So to change a 0 to a factor, you just need to do x minus the zeros, but then that minus needs to distribute to this. So minusing all of this would become a plus 2 minus I squared root of 3, and then minusing all of this would become a plus 2 plus I squared root of 3. Now, even though I've changed these zeros into factors, this is too messy to work with. I don't want to long divide by this. I guess in perfect world, maybe you could keep up with that, and I guess it would probably come out to the same answer, but you don't want to do that to yourself. You really want to multiply these two trinomials together, and that will make it look a whole lot less messy. In fact, I know when I do this, when I multiply these two together, it's going to be some kind of x squared something, so that I can long divide it out of the original polynomial. So that when I long divide it out of the original polynomial, it's going to leave behind a quadratic, and this quadratic is where the last 2 zeros are going to come from. So carefully multiply these two together. So take 3 terms times 3 terms should give us 9 terms. So I'm going to try to color coordinate this to help you see that. But x needs to be distributed to all 3. That's going to give you 3 terms. The positive 2 needs to distribute to all 3. That's another 3 terms. And then finally the negative I square root of 3 needs to be distributed to all 3 terms. Just do I square root of 3. Okay, and then a negative times a positive would be negative. I times I would be I squared. Square root of 3 times square root of 3 would be square root of 9, but square root of 9 is 3. Now, within these, and you need to know this for some other questions too, you need to replace this I squared. So the one that you have to have memorized is this. You need to know the definition of I, and you can always leverage this to discover what I squared is if you forget it. But I can square this side of the equation as long as I square this side of the equation. I squared is equal to -1. So instead of calling this minus 3I squared, I'm going to call it plus 3. It's the same thing. So again, I've got 9 terms here. So one of the hardest things is just keeping up with your work. You don't have to do this, but my way to keep up with this is I just underline the stuff as I go through it. So it looks like I've got 1x squared. It looks like I've got 2x plus 2x gives me 4x. I've got a plus x I squared to 3 and a minus xi squared to 3, so those add to 0. I've got a plus 4 and a plus 3 that could combine to be a plus 7. And then I've got a 2i squared to 3 minus 2i squared to 3, so those add to 0 also. So again, these look terrible, but when you multiply them together, it really just is equivalent to x squared plus 4x plus 7. That's a whole lot easier for my brain to work with long division. So now I'll divide it out. Again, you can't use synthetic division on this. You've got to be able to do long division when needed, as much as you may like synthetic division. First part would be x squared, because x squared times x squared gives you x to the 4th. Also multiply it by this. Also multiply it by this. And my advice is to quickly change the signs and add. These two are supposed to add to 0, otherwise you pick the wrong thing there. These two do not make 5x cubed. If you got 5x cubed, you didn't switch the sign. This would be negative 3x cubed. This would be minus 10x squared. And then negative 13x's plus nothing and plus 14 plus nothing. So those basically just carry down. And looks like I can do this one more time. Now remember that these factors come from these zeros. So even though long division doesn't always have a remainder of 0, this one should. That's what it means to be a factor, is that it divides into it evenly. So I know I have this going for me as a check at the end. Okay, next part looks like it should be negative 3x, because negative 3x times x squared would be negative 3x cubed. Also times 4x. Also times 7. And before you forget, change the signs and add instead. These are supposed to add to 0, otherwise you pick the wrong thing here. These make up 2x squared. These make up 8x, and this makes up 14. 14 plus nothing gives you 14. Alright, looks like we could go one more time, because there's 2 times x squared gives me 2x squared. 2 times 4x gives me 8x, and 2 times 7 gives me 14. This is looking great, because as soon as I switch the signs and add, I get that remainder of 0 that I knew was supposed to happen. So you don't always have that as a check for long division, but if you're dividing out factors or dividing out zeros, by definition, they're supposed to divide into it evenly. So the whole point of all of that was to really divide out the 2 factors that I knew about to expose the 2 factors that I do not know about. And so as soon as I factor this guy, I've got the remaining factors if that's what it's asking for, or set them equal to 0 and solve to find the other zeros that they were asking for. At that point, it's pretty easy. But again, it's great that you can do long division and synthetic division. It's great if you can turn a 0 into a factor. It's great if you can factor or use quadratic formula to solve a quadratic. But you also really need to see how sometimes these skills are intertwined. It's one thing to be able to do them, and it's another thing to be able to know when to use them to help you do something else that you otherwise couldn't do. Okay, so there was a ton to that question. Is that okay? Okay. Is anybody else going to ask about 60? Okay, we still got about 15 minutes, so I can still take another question or two if there's something I can help with. Okay, I'm going to turn the screen off here, but obviously if y'all do find something in the next 15 minutes, please go ahead and ask. Also, just a reminder from the start of class, we are on this moving up schedule today for the moving up ceremony. So you should not go to advisory after this. You should go to your third period or maybe lunch, depending on where your third period is.